Hey guys, so now we'll be looking into the differentiator, which is also an uh, application of operational amplifier. And differentiator is the circuit which produces the differentiation of the input voltage as output. So they are called differentiator for the same reason. And the differentiator circuit which does not use any active device is called passive differentiator, and if they use active device it's called active differentiator. So active device is some device components like operation amplifier, and passive devices are like resistance, capacitor, and etc. So ideal operational amplifier differentiator. So this is the circuit for differentiator, and this is VA input we are providing to the inverting terminal, and RF is the feedback resistance, and current through it is given as I1, and current through the V input is given as I1, and the C1 capacitor is connected to the input, and B is connected to ground, and we'll be getting output as V0. So here node A is also connected to ground, that is virtual ground, and so the voltage at point A will be 0, and input current of ideal operational amplifier is 0. So the entire current flows through the resistance RF. So here I1 is equal to C1 into d by dt of Vin minus Va, and Va we know is 0, so the current becomes C1 Vin by dt, and from the output side we get I is equal to Va minus V0 by RF. RF is feedback resistance, and V0 alone will be taken in output as Va becomes 0, and negative will remain, and negative sign will remain, and so this negative sign is we are getting because of applying the input through inverting terminal, and equating these two equations will be getting V0 is equal to minus C1 RF d Vin by dt, and so here we are getting V0 proportional to differentiation of V into input. So this circuit will produce an output which is a differentiation of the input voltage we provide. So if we give a straight line as input, and we'll be getting spike as output, and if we produce square wave as input, and the output waveform will be spikes like this, and if we produce sine wave, then the differentiation of it will be cosine wave, and if we produce any output, any input, the output will be a differentiation of the input. So disadvantages of ideal operation amplifier are the gain of the differentiator increases as the frequency increases. So if the frequency of the circuit increases, the gain will also increase. Thus, at some high frequency, the differentiator may become unstable and break into oscillations. So these are the possibility that uh, an ideal operation amplifier may go into saturation, and thus the function of it will not be held properly. Then we have practical differentiator, which will differ from ideal differentiator because of some practical disturbances. So here the noise and stability at high frequency can be corrected. The practical differentiator will have a resistance connected parallel to the will have a capacitor connected parallel to the resistor, and this will reduce the amount of noise and disturbances that we are getting. So this is the circuit of practical differentiator, and here the current is given as Vin minus Va by Z1, and Z is the Ri in series with the C1. So this is the current coming out from the differentiator, and here we are connecting an resistance to the uh, other input as well, which is non-inverting terminal, and that input should be equal to RF parallel to R1. So these are the properties and functions of a differentiator.